Looking at the unit circle, we're going to have a go at solving a couple of problems. This first problem asks us to determine the coordinates of the three marked points. This point here is the angle V. If this is the angle V, we can use our standard formula for the unit circle. Any marked angle, V, then the x coordinate is the cosine of the angle, and the y coordinate is the sine of the angle. So this one's quite easy. This one is cosine V, sine V. The angle here, Q, can be expressed in several ways. The angle here, Q, is the angle 90 degrees plus V. So this can be expressed, this angle here can be expressed as 90 plus V. We need to determine the coordinates of this point. This point here is rotated from the 90-degree angle by V. It's going to have a lot of similarities to this coordinate here. We can see the symmetry of the situation. This length here, which represents sine V, is the same as this length here. Now this length here has to determine the cosine of the angle that we're looking at here. And it has to be moving backwards. So this magnitude of this has to be the same as the magnitude of that. They both have this size, sine V. But because we're moving backwards in this kind of direction, it has to be negative. So the coordinate of this point here has to be minus sine V. The y coordinate here has the same as the x coordinate here. The x coordinate here is cos V. That length is the same as this length. And in this case, we're moving in a positive direction as well anyway. So this one is cos V. So the coordinates of point Q is minus sine V, cos V. This also gives us a common trigonometrical relationship such that the cosine of V is equal to the minus sine of 90 plus V. And you can use these type of coordinates to set up little relationships for 90 plus V, 90 minus V, 180 minus V, 270 minus V. You can find all sorts of very simple to use relationships. Our last coordinate R. R is the point 270 minus V. We have this angle V rotated backwards from the 270 point. The magnitude of this particular length has to be the same as that one. This one gives us the x coordinate, and it's a negative coordinate. The length of this side here is sine V. The length of this side here is sine V, but it's moving in a negative direction. So again, the coordinate of this point starts with minus sine V. It's the same as that one, and we can see a vertical symmetry. If we draw a vertical line, it's going to pass through both points Q and R, because these two lengths are the same. The y coordinate is this line down here. It's the same magnitude as the length of this line here. The length of this line here is cos V. The length of the line vertically downwards here is minus cos V. And this gives us the coordinates of point R. Okay, given the values in this table, complete the table. The first ones are easy. We need to find the sine of 0. So an angle 0 will have a point on the unit circle here on the radius. The coordinates of this point is 1, 0. So the y value is 0. The cosine value is 1. We can use the same technique again over here at 90 degrees. 90 degrees is when we rotate up to this point. The coordinates of this point are 0, 1. The cosine value is 0, the x value is 0, the sine value is 1, the y value is 1. So this gives us 1, 0. Now we're going to need to use some diagrams to help us with these last few. We do a quick sketch of the unit circle and draw in the angle 30 degrees. It's roughly like this. If we draw in another angle over here, of 30 degrees backwards in this direction, we're going to create a symmetry. We're going to have a horizontal line like this one, which is parallel to the x-axis. This means that this value here and this value here are the same size. Now what angle is this? If we rotate upwards by 30 degrees and we rotate backwards from 180 by 30 degrees, it brings us to 150. So we see that the sine of 150 degrees is going to be the same as the sine of 30 degrees. They're going to have the same value. The cosines have the same magnitude, but in this case we're moving in a negative direction. So it has to be a negative version of this one. It has to be minus root 3 over 2. Let's do another diagram for 45 degrees. Here at 45 degrees, we draw a horizontal line. We can see that if we move 45 degrees backwards from 180, we'll come to 135. That means that the sine of 45 degrees and the sine of 135 have to be the same. This is roughly 0.707, or 1 over root 2. The cosine of this is going to be the same magnitude as the cosine of 45 degrees, but we're moving in the negative direction again, so it has to be a negative version, minus 0.707. Our last diagram uses the angle 60 degrees. If we draw a horizontal line across, we can find another angle here, 180 minus 60 degrees. This brings us to 120. They're going to have the same sine value as this one. Root 3 over 2. It's about 0.866. This one here, again we're moving in the negative direction, so it's going to have the same value as this one, but in a negative direction, minus 1/2. That's minus 0.5. Okay.